Okay, so hello to everyone. This will be the pre-recorded video in terms of the basic notations and language process in natural language processing. So, let's work on with the discussion though. Pretty much it would be um the content here is having a lot of core topic, but of course we'll just have to make it fast. So in the field of natural language processing, basic notations refer to the fundamental concepts and symbols used to represent and manipulate language data. These notations form the building blocks for more complex tasks, such as text parsing, um, generation, and machine learning. So understanding this notation is essential because they allow us to formalize language and build algorithms capable of processing and understanding text. So um, in our basic notation here in NLP, this is really important to really know about this um, in order for us to build particular project in terms of NLP, basic notation is one of the fundamental area. Um, since studying that one will provides a standardized way to represent those concept, those operations and models for us to um, know clearly and pertains to the implementation, consistent ang ating um, pag-ubra sa galaw. And since NLP involves a lot of there will be computational models. However, when it comes to the details, we're more on theoretical here than what we're trying to prove um, here, there, when it comes to the syntax and semantics. So notation will really help us to represent different NLP models and algorithm. There's a lot of models that we can definitely use when it comes to this one. So basic notation will really act as the universal component, the language that will bridge those gaps between the theory and practical implementation so far. So to make more NLP easy to understand, okay. So these notations are derived from formal language theory, which provides us a mathematical framework for describing languages. And NLP formal language theory help us to define the structure of language model, linguistic elements, and design algorithm that interpret or generate language data. So if we will begin to if you can still remember our discussion in our automatic that there will be a computational models as well that we're able to, I mean, computational methods that we're able to study during those time. And those are actually important still because if we're able to really understand those basics, here in NLP, we're trying to use those approach in order for us to strengthen the implementations as well. So we have here the alphabet, and alphabet is what we've known. This is actually denoted as the sigma, is a set of characters used to form words and sentences. And in NLP, the alphabet defines the basic building blocks from which all text data is composed. So the alphabet can include letters, numbers, punctuation marks, and other specific special symbols depending on the language or data set. So we've all known that alphabet in our automata were able to also use this one in representing especially in BFA if we will be going to particularly use with, for example, we have um Q0, then direct to Q1. The alphabet we can use, for example, is A, or it would be zero, whatever. Those are that is actually the purpose of alphabet. Here in NLP, alphabet, for example, you have Q1, um, Q0 to Q1A, and and here for there the Q2, and then Q3 will be our final state. For example, you have letter D here, so of course you have and string that can definitely um from the initial state to the final state, you can build string of and. Okay. So it will be the same thing here, but the representation we're also working on with the words already here in NLP. So what's the importance of alphabet in NLP? So tokenization, the alphabet is essential in tokenizing text. It will break down a sentence into smaller units, tokens, such as words or punctuation, which are crucial for further NLP tasks like part of speech tagging, linked entity recognition, and sentence analysis. Say, for example, here then, this is our um, string. So you will begin to separate this one, separate everything that is actually tokens. We're trying to simplify this string into separate tokens in order for us to really be ready when it comes to the um, implementations afterwards. So the in text and presentation, the al we also have here understanding the alphabet is crucial for encoding text in machine-readable formats. It provides the foundation for converting raw text into vectors that models can process. So particularly for this one, um, in terms of the text representation, um, we are still using the alphabet. Since of course you cannot begin to read specific um string. Actually, if you I'm so sorry. Since sa ating mga text representation, we're dealing with text, we're transforming raw text into vectors. So the NLP models can help us to strengthen those one. So the basic notation in NLP is really understand this alphabet, since this is really essential as it will help to really convert text into the format. For example, na that ang ating machine maka-intindi sila. So by encoding the text into the machine readable vectors, NLP models can process and analyze the content more effectively ang siya. So say for example, we have here the specific alphabet. So we have the string of letters represents the alphabet of lowercase and English letters. We also do have a set of comprehensive alphabet that includes uppercase letters, digits, punctuations, and so on and so forth. So those are the alphabet. Now, we also have strings and words, trying to understand that one and what will be the importance of this. So a string is a finite sequence of symbols um, chosen from the alphabet, and a word is specific instance of a string that typically represents a meaningful unit in a language. It's what we do have earlier. We were able to build A and E D in our states. So sa ating automaton. So by reading that from the initial state direct to the final state, which is here then, we can read and since that is being concatenated, when we say concatenated, say for example Q0 and Q1 do have A, and you will concatenate N. So there will be epsilon. That's how we were able to work on with in terms sa NLP na sa automaton na to. Here, um, we are still observing those kind of concatenations also from the set of characters. By concatenating them, we can perform or we can definitely can form a particular string. So this is really essential, actually, since strings and the words we're trying to play that here in automata. I mean NLP. So the operations that is important here is concatenation. This is joining strings or words together to form a longer string and then repeat. This operation is fundamental because words and sentences are constructed by concatenating smaller units like chapters or shortcuts. So in our observation class, we are actually using the concatenation. Say for example, sa mga past and present principles or past tense or future tense. You can concatenate that with prefix or suffix. So that's why it is really important to really study this kind of situations after the NLP. Now, the importance in when it comes to sentence formation, um, words are concatenated to form sentences, which are the basic units of communications in NLP. Models like transformers and RNNs process sequences of concatenated words to perform tasks like translation, summarization, or sentiment analysis. So when it comes to sentence formation as learning this approach for the strings and the words, the operations, of course, is really crucial since as what I have mentioned earlier, um, we can combine those particular words, for example, to create sentences, which are the fundamentals for communications, of course. So models like the transformers, mga advanced techniques, um, can process the sequences of words to carry out the task, such as the translations that we mentioned, the summarization, and that sentiment analysis also. Okay. Next, will be when it comes to text generation. In language model, concatenation, uh, concatenating generated words create longer passages, and then, sorry, longer passages of coherent text. So when it comes to this one, and in NLP, text generation involves concatenating generated words to formulate longer passages of coherent text. So this process actually will really allow us to or allow the language models to produce a meaningful and contextually contextually like relevant yung mga sentences, which really enables tasks such as creating of new content, dialogue system, and pwede man mga creative writing. Okay. Next will be when it comes to the language models. Concatenation helps create sequences in language models such as R and N, where sequences are formed by joining predicted words over time. So, as what I have always mentioned, that concatenation really play a key role for these language models, where it really helps to form long sequences by joining those predicted words step by step. And it will allow the model to generate the certain output or coherent output, like sentences or paragraph based on the previous context and connections as well. And next would be text processing. When it comes to text processing, it will um, allows for combination of words, characters, or even entire documents, which is important in tasks like document classification, text summarization, and question answering. So in this particular field, in the text processing, we're still involved in combining words, characters, or entire document, which is really the task for the document classification for summarizing. Um, This process will really help us to organize and really extract meaningful information from the large text data to address the specific certain field or task effectively though. Now, after we have here a particular example of concatenations, if string 1 and string 2, you have dog and the cat, concatenating them will produce cat dog. So in NLP, this operation used extensively in tasks like text generation, like generating the sentences the cat chases the dog. So NLP, a model might concatenate tokens like that actually since to form a complete phrase like the the cat chases the dog. So of course, concatenation is one of the thing that plays I mean one amo gina siya ang main function sa concatenation na maka-form ng new sentences or structures. Okay, let's proceed for the next one. All right, so next here is actually the length of a string is denoted as the that symbol, which is um, the W. I'm so sorry. There's someone shouting. 1 second. Let me just attend to this for a while. Okay. So for this one class, the length of a string is denoted as the cardinality of W. And then where W is a string in question. It refers to the number of symbols or characters in a string. In NLP, the length of a string is important for several tasks, such as sentence segmentation, cutting, sequences for models, and controlling the flow of the text processing. So particularly in NLP class, we're actually using this length of a string since it is the crucial for the fast flows like the sentence segmentation where our system could identify the end of the sentences for padding sequences for modals. This is actually to really ensure consistency in terms of the input length. And this will also will control the flow of our of text processing, especially when dealing with variable length text input in machine learning models. So let's proceed. So the significance of this length of a string when it comes to the text processing, knowing the length of the string will really help in text segmentation, such as splitting long documents into sentences or specific word. So that's why class the concept of length of a string is really important since in terms of knowing the length of particular string for that is really essential for text processing also, as it will aid in text segmentation tasks. For example, the length of a string will help in splitting long documents into such manageable parts, such as sentences or words, that will ensure that model can process them efficiently also. Next, we have here the model input. For the model input, many machine learning models require fixed length input sequences. Understanding string length help with padding sequences to ensure uniformly in the input size. So particularly in this field class, under the string length is crucial for the model input, as many machine learning models require a fixed length input sequences also. By knowing this is we can really apply padding to shorter sequences, ensuring uniformity in the size input. which really help our model to strengthen the implementation process and learn from the data effectively though. Next will be the when it comes to performance metrics. So performance metrics, the length of the string is used in performance evaluation, such as calculating the length of summaries in text summarization tasks. So it plays a key role in performance metrics also, because such as evaluating the quality of the summaries and text summarization tasks. It will help measures the length of the generated summary, comparing it with reference summaries and ensure the output meets the specific length requirements or standards. So for example, sa inyong, if in terms of ChatGPTs or any AI tools, you will begin to also ask, generate in this particular 200 words, or especially in your online quizzes na mga essay, AI na lang, and there will be 5 sentences, so you're able to mention nga amo na siya ang imong minimum requirement. So that is the concept of length, wherein useful should grammar field. So the example, if the string hello, then the string is equals to 5 because the string contains 5 characters. So that's actually the just this, for example. We also do have here the anti-string symbol and use the epsilon and the lambda, and it is a string with a length of 0. Although the empty string doesn't contain any symbols, it is still a valid string in formal languages and plays an important role in NLP. So in our automata class, I know that we're able to deal with epsilon when it comes to concatenating. I know that we know that the length of that is definitely 0, but it doesn't contain any symbols. It is still considered actually a valid string as what we have already known in our formal languages. So the empty string will really play an important role in various tasks, like for example, sa mga handling edge cases in text processing, representing missing or null values, and serving as a base case in recursive algorithms or specific models. And then we also have here the in terms of concatenation. So as what we had mentioned some ating automata before, we're using for concatenating, we're using empty string. So empty string behaves neutrally in concatenation when it is concatenated with any other string. The result is the original string. This property is useful when performing text generation or processing tasks where an optimal element like a word or punctuation mark may or may not be present. So in NLP, the empty string plays important role with that when concatenated with another string. So the result is still simply the original string though. For example, if um, Sir Sir Max tapos concatenated with epsilon, of course it will still be Sir Max. So that's how it works. Um, the this property is actually useful when it comes to like text generation bala mga um like words or punctuation marks. So since for example Sir Max, you will put their punctuation, so you can actually use that the epsilon. Although may not be shown, but if you will really study that one, when it comes to their Sir Max concatenating that um the question mark, so it will become Sir Max question mark already. So and it will be added. However, it will not affect the overall structure of these three so far. Now, in terms of handling missing data, the empty string often represent a missing or incomplete information in an NLP task. For example, when handling data with missing words or tokens, the empty string can signify a gap or a placeholder. Of course, since the problems up in the NLP, there will be zeros might get missing data. So the empty string is often used to represent those incomplete information. Like for example, when dealing with data sets that have missing words or tokens, the empty string can serve as a placeholder for those gap. I mean placeholder or gap that will really indicate that a particular element is definitely not there or absent. This will really help to strengthen or to maintain the integrity of your data set, and it will allow consistency for the process. So we also have here in terms of grammar rules. In formal grammars, the empty symbols that string is used to represent a non-terminal symbol that can optionally be replaced by nothing. This is especially useful for defining optional components in sentences like optional clauses or punctuation. So in NLP, we know that the empty string is crucial in formal grammars as it represents a non-terminal symbols that can optionally be replaced by nothing. So we already know that in our automata. So this is particularly useful for defining optional components in sentences such as optional clauses or punctuation, allowing for flexibilities in terms of those sentence structures while maintaining the grammatical rules. Now, for example, for any string W concatenated with empty string or empty string concatenated with W, it will still be the string. In text processing, epsilon can represent an optional word in a sentence actually. So that's how it works. Now, understanding basic notation in NLP is such as the alphabet, the um, string length, and the empty string is essential for building algorithms that can process and understand natural language. These concepts form the foundations for more complex NLP tasks like the segmentation, translation, text generation. Mastering those notations will provide the necessary framework to tackle more advanced applications in NLP and artificial intelligence. So that's why class, those are the crucial thing for developing algorithms that processes and interpret natural language. Though so this foundational concept enable more complex NLP tasks like those segmentation and so on. So therefore, mastering this notation will really help us to create the framework necessary to address the advanced applications in both NLP and AI field. Now, we also have here the exponent operators on strings like W to the power of n and its application. So the exponent operator applied to a string W is denoted as W to the power of n, where n is any positive number or integer. This operation means repeating the string often for how many times. In other words, W to the power of n is a string formed by concatenating W with itself n times. So the exponent operator class applied to a string W denoted as that W to the power of n represents repeating the string for how many times that you've declared. So for example, Sir Max to the power of 3, so Sir Max, Sir Max, Sir Max, like that. This operation is useful in various tasks for generating repeated patterns or structures in our text. And then the significance in terms of pattern construction. So this operation is definitely used to generate repetitive structures in text or language models. For example, in text generation tasks, repeating certain patterns or structures can create more coherent outputs. So it is a significant actually in this field for pattern construction as it helped generate repetitive structures and then by repeating specific patterns and so on, then this can create more coherent and consistent output in tasks like generating where the model may need to produce repeated phrases or sequences to maintain flow and meaning. Like sa mga AI tools, they do have certainly sulit-sulit in every ano um in every chat mo. Actually, mga siya, mga linili, that is needing this kind of um, operation. So, the significance for this one, in terms of token repetition, some NLP tasks such as the data, augmentation or style, um, transfer can involve repeating certain tasks, tokens, or characters to create variability or mimic specific linguistic style. So, repeating certain tokens, class, or characters can introduce variability in text, which will really help in training models to generalize better. It can also be used to mimic specific linguistic styles or patterns, which will allow the model to really generate text that will align as also with particular stylistic or syntactic preferences. So those are the um, that's why it is really significant in this field. So next will be for sequence modeling, when working with RNNs or transformers, these operations can help create cyclic or repetitive patterns and sequences useful for modeling language structures like rhyme or rhythm and poetry. So in sequence modeling class, when working with with those models, repeating sequences or patterns can really help capture cycle or repetitive structures in language, which is usually or especially useful for the task like those rhyme or rhythm, so on and so forth, especially for mga stylistic element like song lyrics or dialogue generations that will enable the model to generate more natural and contextually relevant outputs. Now, we also have here a specific examples. If W ABC, then string to the power of three, which will turns to ABC, and so on. In NLP, these operations can help create repetitive structures in tasks like text augmentation, where the strings hello might be repeated multiple times to create variations. Whereas those are the situations may happen here. Now, we have the reversal of string. So for reversal of a string, W denoted by W with the R, which means reverse, involves writing the strings in reverse order. This operation is especially important when dealing with palindrome words or phrases that read the same backward and forward. We know that we all know that we're working on with the reversal in terms of your data structures for this particular field, the reversal. So here then, for example, hello, reverse that to all name. This operation is particularly useful in NLP tasks, such as identifying palindromes also, words or phrases that read the same forward and backward, is what we mentioned. And in various string manipulation, of course, like where the order of characters need to be reversed, there will be something like that. Okay. The significance of this in the field of NLP or text analysis, reversal or string can be useful in tasks like spell checking, text comparison, or detecting symmetry in sentences. For example, in sentiment analysis, checking if a reverse sentence has the same meaning can provide insight into negation or the irony. So for the text analysis class, the sorry, string reversal is significant for this task also, as it can help in detecting symmetry and so on and so forth. For example, in sentiment analysis, if checking if a reverse sentence maintains the same meaning can reveal the subtle nuances, such as when a sentence has negation, like not good versus good not, like that. It also aids in spell checking and text comparison, enhancing the accuracy of the NLP models in understanding the context in the meaning of also. When it comes to Pattern matching. This operation is also relevant in tasks like pattern matching, where the order of words or characters may be important, and reversing a string can help find some symmetrical patterns. So still, um, here that this is really serving important role, where the order of words for characters is crucial. Reversing a string can help identify symmetrical patterns or sequences, which is definitely useful for tasks like finding the palindromes, detecting mirrored phrases, or even matching patterns that will involve reverse order, such as in some cryptographic or maybe linguistic analysis. Now, we also have here for natural language generation. In generative models, reversing strings um, can be used to introduce variety or apply stylistic constraints in certain tasks like poetry generation. So reversing strings can introduce variety or apply stylistic constraints, such as creating mirrored or symmetrical structures in tasks like poetry generation. This will really help the model also to generate more creative and would be diverse output, adhering to specific linguistic patterns or stylistic preferences. Now, we also have here example for the palindrome. When we reverse that, the madam will still be madam, since that is a palindrome. For a non-palindrome, hello to Ole. That's how it is. Now, let's actually proceed to the substring. Substring, we're still studying that here then, since that is really important when it comes to this field. When we say substring, as of a string W is any sequence that can be formed by taking contiguous symbols from W while preserving the text. The order of the original string, substring are essential for many text processing tasks, especially in pattern matching and string comparison. Say, for example, um, from the word teacher, the substring that you can build will be teach. So teach will be different and teacher is different also. Like for example, adding prefixes or adding suffix could strengthen also here in this field. So substrings are essential in many text processing tasks such as pattern matching, comparison, searching for specific sequences or patterns within the larger text. They help in identifying relevant portions of text for further analysis or processing so far. So, okay, there's so the significance of this field when it comes to their NLP text search and matching. So substrings are used extensively in text search algorithms where you need to find specific patterns within the text. For example, regular expression. In NLP, rely on substring search to find words, phrases, or specific patterns. I'm sorry, class, if you can hear something any noise because I also have my master's class just right now. I'm just doing it just multitasking here. Okay, so substrings are crucial for text search and matching tasks, actually. So they are used in text search algorithms such as the regular expression to find specific words or to phrases and patterns within the larger text. So this will allow models to and tools to identify relevant portions of text efficiently. I mean, enabling tasks like the keyword extraction, pattern recognition, and information readout. Now, when it comes to the named entity recognition, we are also using substrings. Substrings will help identify specific parts of text, like the names or location, which are important for this particular field. So, when it comes to the name entity recognition class. So substring, we're able to use that there by extracting the substrings. The NER systems can classify and label entities within the text, which is crucial for tasks like information extraction, mga summarization, question answering, and so on and so forth. So, um, in our NER, the substring will help identify specific parts of the text, such as names, the location, dates, and other activities also of a string function. Okay. So for text segmentation, breaking down a larger corpus into smaller, meaningful units often involves finding substrings that represent tokens or phrases in the text. And then um, here, text segmentation relies heavily on identifying substring that represent meaningful units such as tokens, words, or phrases. By breaking down them, a large purpose into a smaller, manageable pieces, NLP systems can more easily analyze and process the text, enabling tasks like sentence segmentation and so on and so forth, and enabling um I mean this substring will really help to improve the efficiency and accuracy of downs of those particular field, just like the machine translation, sentiment analysis, and summarization. Okay. When it comes to the prefix, we also have prefix here. When we say prefix, that is a substring. It consists of the beginning segment of a string. For example, the prefix of hello will be hello, hell. So we all know about that already. And for suffix, it is a substring. It consists of the ending segment of a string. For example, the suffix for hello will be low. Already it's understandable already. Now, the significance of prefix and suffix in NLP, stemming and lemmatization. So, stemming and lemmatization, prefixes and suffixes are essential in tasks like this, where you um, strip affixes, prefixes, or suffixes to derive the root form of a word. So, like I said earlier, that in prefix and suffix, we're trying to work on the past or present principles. So that is really necessary here. Because, for example, running, that is like that is an example of in stemming. Running might be reduced to run, and in nematization, better might be reduced to good, like that. So this will really help improve the efficiency of text analysis by understanding words form, enabling better matching and understanding across variations of words. So far. Now, next will be text compression and search. Identifying prefixes and suffix helps in text compression algorithm like the Huffman coding and efficient searching technique. So in this particular field for text compression and search, um, prefix and suffix play a crucial role still here. Identifying common prefix and suffix compression algorithm, they like Huffman coding can reduce the size of the text by replacing frequent patterns with shorter representation. It will recognize that this affixes enhances to the efficiency of the search algorithm by improving the pattern matching. Will help quickly to locate words or substring with shared prefixes or suffixes. So this reduces the computational complexity and speeds up both compression and search operation. No? So for example, we have W for computer, prefix could be com, and suffix could be ter. It's actually just an example. Now let's actually move on. So next, we have here the example for substring search. In task like text search, finding cat as a substring within concatenation can be part of a word search or pattern matching task. That's how it works. So we have here the basic notations also. Let's proceed with this topic. Basic operation. Concatenation, exponentiation, reversal, and substrings are fundamental in NLP for manipulating and analyzing task or text data. Studying these operations allows NLP practitioner to process text efficiently, detect the patterns, generate language, and improve model performances in various applications, such as machine translation, text generations, and information retrieval. So this three, I mean those cases, plus informational in NLP for manipulating and analyzing text data. So understanding those operations will really enable us to efficiently process the text, detect the patterns, generate language, and enhance the model performance. And this operations is really important for those kind of fields where handling text in various forms and structures is the key to building effective NLP systems so far. Now let's actually move on. The formal context, formal language theory, formal language over an alphabet signal. It's defined as any um, sigma with a power of asterisk, which is a set of all the possible strings that can be formed using the set symbols in the alphabet. A formal language is a collection of string of words that follow a specific set of rules or patterns, which can be generated or recognized by computational model. So in this context, class, a formal language consists of strings that follow specific rules or patterns. That patterns can be generated or recognized by computational models like the finite automata or regular grammars. Those are the foundations in computer science and NLP, as that will really help in strengthening or designing the models that will process and analyze the text according to the according to the defined structures or rules. Now, what's the significance of the formal language? Okay, so let's actually proceed here. The significance of formal languages in terms of um, text representation. So, text representation, formal languages, serves as a way to represent the structures of natural language in a formalized manner. In NLP, this is um, essential for tasks like parsing, understanding the sentence structures, and compiling, translating high-level language into machine code. So, um, in terms of this class, this is essential for tasks like the parsing, which we mentioned already. Um, as the formal languages will really provide a structured, um, formalized way to represent natural language also. So our goal actually, where the goal here is to understand the structures of sentences kung sa parsing. And for compiling naman, where high-level language like programming languages is translated into machine code. By using formal languages, NLP systems can analyze and generate language based on well-defined rules, improving the accuracy and efficiency of language processing tasks. So that is actually how does that work. Now, modeling grammar is the next one. Okay, not okay. So sorry, naglag ako ng Zoom. Go. This is the for text representation, and for modeling grammar, go back. Check ko ba? Yeah. Akong PC. Bubers ni bubers. Second, i-pause ko lang ano. Let me fix this. Okay. I'm so sorry, class. It is really so hard to manage doing multitasking here on my laptop. I'm also attending my class for my master's for bioinformatics in here and my PC I'm also working on for your for you then. Here, so let's proceed with modeling and grammar. For modeling and grammar class, formal languages provide a mathematical framework for defining the syntax of languages. NLP, in NLP, this framework is used to define the grammatical rules for constructing valid sentences or phrases in language. So, in NLP, the formal language provide a framework or mathematical framework for modeling grammar then, which is essential for defining the syntax of the language. So that framework will allow for a specification of grammatical rules that will dictate how valid sentences or phrases are constructed. Now, by using formal languages, NLP systems can ensure that the generated or parsed text adheres to the grammatical structures of the target language, which enable tasks such as syntactic parsing, sentence generations, and language understanding so far. Well, let's go next for next book. Movement. Okay. Example. Um, if string if sigma equals, we have the alphabet of a and b, then the sigma asterisk consists of a possible strings formed from a and b, such as a b sets or subsets the combination rather. A formal language would be a specific subset of this set, such as language a, and a, where only strings of a are included. So in our automaton, we're able to play that one actually if there will be a set of alphabet A and B. If we do have string, alphabet plain star, so it can be right as much as zero or more A or B. Now, here, okay, next. Okay, so infinite nature of the this one, the alphabet, and its implication for formal languages. So the set is infinite for alphabet to the power of asterisk or clean star is infinite because it includes all the possible combinations of symbols from the alphabet, including strings or arbitrary length. This means that for any alphabet, the set alphabet contains an uncountable numbers of strings leading to certain challenges when working with formal languages. So that's how um, it works. So the set is infinite because it includes the possible combination layer, as what I mentioned, zero or more A or B. So this introduces the challenges when working with formal languages such as managing and processing and unbounded numbers of possible strings. So to address the challenges, computational models often focus on subsets of this um, alphabet to the power of clean star that are finite or manageable, allowing them to effectively recognize and generate meaningful strings within the context of a specified task or specific task. Now, the significance of this one in terms of NLP, defining a language, since alphabet clean star is infinite, defining a specific formal language requires operations to limit the scope of what strings are considered valid. For example, we might define a language that only includes strings of a certain length or that adhere to specific patterns, such as strings containing an even number of eights. So in this kind of scenario, um, in NLP, defining a language within the set of string to the power of clean star is crucial because this is infinite and we need to limit the scope of what strings are considered valid. So to do this, operations are as defining constraints on strings length or specific patterns are used. For example, a language might be defined to only include strings of a certain length, or those that follow specific rules, like containing an even number of leaves. So this process allows for creations of manageable, meaningful languages, which can then be processed and analyzed by computational models for tasks such as the parsing, generation, or classification. Now, for computational complexity, working with, excuse me, with the alphabet clean start introduces computational challenges as it becomes impractical to directly enumerate or process all strings in the infinite set. Efficient algorithms and formal operations such as regular expressions or finite automata are employed to handle this infinite set by focusing on specific useful subset. So here then class in NLP working with this clean star alphabet introduces computational complexity because directly enumerating or processing all strings in the infinite set is impractical. So to address that, efficient algorithms and formal operation, such as regular expression or finite automata are needed to handle specific useful subsets of this particular alphabet. So this method will allow system to focus on finite set, manageable portion on the infinite of the infinite set, making tasks like pattern matching and so on feasible and efficient. Okay. Now, next, in terms, example here, consider the alphabet string AB. The set clean star is infinite, and the formal language could be, we have here the strength, the string, um, sigma, epsilon, the alphabet string, where the string contains a given number of A's, restricts the infinite set of strings that meet the specific criteria, such as containing an even number of A's. So therefore, there will be limitations that has been declared right there. So that's how it works. Now, let's proceed with another. Okay, so let's actually continue. We have the next. Wait, no, there's one next. Um, all right. So formal languages, operations like reversal, um, concatenation, and clean closure, clean star. Formal languages can be manipulated using various operations, each of which serves a different purpose in defining and manipulating the structures of languages. Some of the most important operations in formal language here include those, like the one that I mentioned. So let's actually deal with that one by one. So when it comes to reversal of language, we're trying to reverse specific language, denoted as L to the power of R or LR, involves reversing all the strings of the language. L is a set of strings, then R is a new set where each string is uh, in L is reversed. So as what we mentioned earlier, my um ano pa, we're able to um reverse the specific string. I'm sorry. Let me just ano dami ha sa masters. Okay, we're already done with the reversal earlier. That is useful in tasks like identifying the palindromes or detecting mirrored patterns, as what we have mentioned earlier. Then the next, the significance for this, handling palindromes reversal is particularly important for tasks like detecting palindromes, words that read the same backward and forward, or working with language constructs that require um, understanding both directions of a string, like context and subject parsing. So we've known that trying to detect if for sentiment analysis, especially if subjective is or objective, we like that. If mutated the structures there. Now in string matching, reversal can also be useful in searching for substrings in a reverse text or for text compression techniques that involve reversing string patterns then. And then example, we're done with that. So A, B, C, D, E, F, or C, D, A, or Fed. That's how we'll be doing with that operation. Now next will be the concatenation, L1 and L2. So concatenation of two languages, denoted as that, involving combining every string from L1 with every string from L2 to form a new string. The resulting language is a set of all possible concatenations of strings. So we're just simply combining them. Now, sentence construction is used in language generation tasks where multiple components like subject and predicate are combined to form complete sentences. Of course, this is actually the function that we're trying to work here. Um, we're definitely combining um, them to certainly um, for us to combine a new structured sentence. Then, when it comes to text parsing and understanding, so in context free grammar, um, Parsing concatenation allows the combination of smaller syntactic units like noun, phrase, and verb, I'm sorry, or phrase to create longer construct, such as um, complex sentences. So that's how it works. Um, Next then, for example, your L1, um, you have cat, dog, and then chases and sleeps for the L2. Then L1 and L2, cat chases, then cat sleep, dog chases, and dog sleeps. So those are the combinations that we can derive from that from that word. And then we have here for the clean closure. For clean closure, we mentioned it earlier that this is the um this is actually the denoted into the clean star refers to the set of string that can be made by concatenating zero or more strings from L. It also includes this empty string. Clean closure allows the constructions of language with repetition, such as language with an arbitrary number of repeated tokens. So in this kind of state class, we're trying to work on with signifying many there will be from zero or more words. So pattern recognition, generation, clean closure is fundamental in regular expression where it is used to specify patterns that can repeat number of times. Helps model repetitive structure in text such as matching any number of vowels or consonants in a string. So pattern um, recognition or a generation, we're trying to deal with this clean closure from first. Afterwards, modern infinite sequences. It allows formal models to represent um, patterns that can occur in arbitrary number of times, such as identifying repeated phrases and text generations or token recognition. So this will be the significance of this communication. And then examples, A, B, then the combination would be like this. And then includes with the empty string because that equals with zero or more data. Now we also have here the formal languages and their operations such as reversal, concatenation, and clean closures are the central to computational linguistics. Ano to? Where are we? And natural language processing. These operations allow us to model, manipulate, and process linguistic structures in a mathematical rigorous way. They are fundamental, foundational to tasks such as parsing, language modeling, and text generation, which are core components of many NLP systems. So this particular field, we're absolutely working on with when it comes to those operations. So it will provide a mathematically rigorous ways to model, manipulate, and process linguistic structures as they form the foundation for key NLP tasks like the parsing, where the structures of sentences is analyzed, language modeling, where the patterns in language are learned, and the text generation, where new coherent text is created. So these operations enable the design of efficient algorithms and systems that we process and generate natural language effectively. Next, by understanding how formal languages are defined and manipulated, NLP practitioners can design um, more efficient algorithms and models for handling natural language data, leading to advancement in fields like machine translation, speech recognitions, and information reval. So in this particular field class, this is really important for us to understand since As what we mentioned, this is going to be useful in terms of those machine translations, speech recognitions, and so on and so forth. And then there will be um, language classes, refers to categories of um, that share common properties, particularly in patterns, in terms of their expressive power and computational complexity. These classes provide a way to understand and classify languages based on the complexity of the computational models that can recognize or generate them. So in this field class, um, language classes is also important. So actually, class, language classes is based categorized formal languages based on their complexity and the computational models that can recognize or generate them. So this classification, like regular and context free languages, help determine which algorithms and models are suitable for tasks, thus parsing and text um, processing in NLP. So let me run through here next the significance of these language classes. Um, Understanding explicit power. So language classes help in understanding the scope of what a computational model can process. For instance, some languages may require more complex computational models to parse or generate, while others may be simpler and more efficient to process. So in NLP, understanding language classes is crucial for assessing expressive power of computational models. Some languages requires more complex models like the context sensitive grammars for tasks such as parsing generation, um, while simpler languages like regular languages can be processed more efficiently with less complex models. So here then the significance in NLP, model selection, um, different languages classes require different um, requires different you know um automata or grammars. For example, regular languages can be processed with finite automata, while context-free languages require more complex models with Persian automata. So understanding more complex models like Persian classes, I mean language classes, help select the right model for NLP tasks such as parsing, machine translations, and speech recognition. So in this field class relies on understanding language classes as different classes require different application models. For example, the regular languages can be processed efficiently with finite automata, and while the context-free languages need more complex models like Russian automata, which we were not able to discuss in our automata period, helping to choose the appropriate model to forecast the parsing, machine translation, and speech recognition. Now, next will be the example. Regular languages include patterns like phone numbers, um, excuse me, phone numbers or email address. This can be efficiently processed using some simple models and like finite automata. Context-free languages include programming languages or sentence with hierarchical structures. These require context-free grammars and are more complex. So this is the example then. Now we have here the closure properties of languages. What does it mean for a class to be closed under an operation? The closure property refers to the ability of a language class to remain within the same class. When certain operations um, are applied. Specifically, a language class is said to be closed under an operations if applying that operations to any two languages within the class results in a new language that is still within the same class. So closure property in our formal language theory refers to a language class ability to remain within the same class when certain operations are applied. Diba? So a class is closed under an operation if applying that operations to languages within the class, like mga concatenation or so on, results in a new language that also belongs to the same class. Yung mga ano na siya, no? Diba sa automaton, pwede na, ano-ara na. This concept helps in understanding how languages behave when manipulated by operations, which is crucial for designing efficient computational models in our NLP. Now, we also have here the significance in NLP, the consistency in terms of consistency and operations. Ensures a closure property ensure that applying operations like concatenation, so on and so forth, to languages does not result in languages that fall outside the class. This is essential for NLP tasks that involve combining or modifying languages, such as the grammar, generation, compiling, or query processing. So, in NLP class, closure property ensures that applying for operations that those field um, to languages within a certain class does not result in languages that fall outside the class. So this is crucial for tasks like grammar generation, so we mentioned, compiling, pair processing, as it guarantees the result saying the languages remain manageable and consistent with the computational model. Now, next, in terms of predictability, closure property makes it easier to predict the outcome of processing operations, which is vital for designing efficient tool parsers and um, co- and compilers in NLP. So, regarding with this one, in predictability class, closure properties makes it easier to predict the outcome for the processing operations, as it ensures that the result remains within the same language class. And this predictability is vital for designing efficient parsers and compilers, as it will help in processing language structures consistently and accurately. Now, the example for that, the regular language is closed under union concatenation between kosher. This means that L1 and L2 are regular languages. Their union, L1 union 2, and concatenation L1 times N2 will also be regular languages. Of course, let's the languages as they will be concatenated or whatever, what kind of operations under. So if L1 it's a regular language between closure will also be other regular languages since that is still belong to that set. However, context-free languages are not closed under those section with regular languages, but they are closed under union and concatenation. Yeah, you just have to take from those things. Now, the key properties to consider membership problem, um, recognition algorithm, and parsing algorithm. Now, what is membership problem? The membership problem involves determining whether given string belongs to a specific language. This is a fundamental task in formal language theory and plays a critical role in NLP tasks, such as text classification, spell checking, and syntax checking. So the membership problem class involves determining whether a given string belongs to a specific language. In NLP, this problem is crucial for tasks like text classification, spell checking, syntax checking, where it's necessary to verify if for a specific string conforms to predefined linguistic patterns or roots. Now, it is also significant in terms of efficient query processing. So, in applications like search engines or information retrieval system, it is important to efficiently determine if a given string, such as a query or a document, belongs to a certain class of text, like a list of legal documents, valid sentences, and etc. So efficient query processing class in NLP is essential for application like those being mentioned, search engine, and so on, where it's important to quickly determine if a given string, such as the query or specific document, belong to a specific class, like valid sentences or legal documents. So, as this will ensure faster and more accurate retrieval for of relevant information, improving the efficiency of the system. Now, in terms of text classification, excuse me, in NLP, we often need to determine whether a string, like a sentence or a word, matches a given pattern, which is central to applications like sentiment analysis or spam detection. So in NLP, involves determining whether a string, like a sentence matches a given pattern, which is central to tasks like sentiment analysis or spam detection. This process will help categorize text based on content, enabling system to understand and classify inputs efficiently for better decision making. Next, um, grammar checking. In grammar checking and syntax analysis, the membership problem helps determine whether um, a sentence follows the rule of a given grammar, like whether a sentence is grammatically correct according to a context-free grammar. So in NLP, grammar checking relies on the membership problem to determine whether a sentence follows the rules of a given grammar, such as the checking if a sentence is grammatically correct according to the CFG. This process is crucial for tasks like the syntax analysis, as it will ensure that text adheres to the expected grammatical structures before further processing or understanding. So, for example, given a context-free grammar that defines a valid sentence structures, the membership problem would ask, does the string, the cat sleeps, belong to this language? So, given a context-free grammar, that is actually the example that we can consider. So, sorry, let me just check lang kung may pumuntok na picture naman. Okay. So, given a context-free grammar class that defines a valid sentence structures, like for example, um, like to mga sentence viewing, you have the determiner, may noun, may verb. So the membership problem would ask, like for example, does the string, um, the cat sleeps, so belong to this language. So the task is to determine if this string can be derived using the rules of the grammar, which is in this case, it can be, since that is a determiner, then cat is a noun, the sleep and sleep is a verb. So making it a valid sentence in the language. Okay. Now let's proceed with the recognition of algorithm. Recognition algorithm are used to determine whether a string belongs to a language, and if so, identify its structures within its language. Within the language, their algorithm process strings and verify their membership in the language while building their syntactic or semantic structure. That means to say, it is being used to determine if a strings belong to a language, and if so, to identify its structures within the that language, these algorithms process the input strings, verify um, its membership in the language, and build its syntactic or semantic structure, which is essential for tasks like parsing, grammar checking, or text analysis in NLP. Now, um, significance in NLP in terms of recognition algorithm, it is in terms of the fields of parsing. So it in tasks like machine translation or syntax analysis, recognition algorithms are used to parse sentences into their grammatical structures. For example, dependency parsing analyzes these syntactic dependencies between words in a sentence. So in NLP, Parsing relies on recognition algorithms. So to analyze and break down the sentences into their grammatical structure. For tasks like machine translation or syntax analysis, algorithms such as the dependency parsing are used to identify syntactic dependencies between words in a sentence, helping systems understand the relationship embedded within the text. Now, afterwards will be pattern matching. In terms of pattern matching, in information's retrieval and text search, recognition, algorithms help identify matches to predefined patterns, such as identifying keywords in the documents. So, therefore, in NLP, pattern matching is crucial for tasks like information retrieval and text search, where recognition algorithms are used to identify matches to predefined patterns, such as finding specific keywords in documents. These algorithms enable efficient searching and retrieval for relevant information based on the presence of these patterns, improving accuracy and speed in text-based application. Now, in terms of pattern recognition also, this, I'm sorry, nagpa mo sa tools, I mean sa analyzer, para sila okay. Pattern recognition, these algorithms help identify key patterns or elements within a sentence or document, such as names, entities, or verb phrases. So, pattern recognition, actually, in terms of this field, so um, it has been used to identify key patterns or elements within a sentence or document, such as name entities, names, peoples, or locations, or word phrases. These algorithms enable systems to extract meaningful information from text, supporting tasks like name entity recognition, information tech extractions, and semantic analysis. So, sorry, for example, um, finite automata are used to recognize strings in regular languages by traversing um, a sequence of states. For context-free languages, procedural automata can be used to recognize strings and build a parse tree. So it has been used to recognize strings in regular languages by traversing a sequence of states. For example, the finite automaton can recognize strings like AB or AAB, AABB, ano pa na, by processing one character at a time, moving through its states according to a set of transition rules. So for context-free languages, procedural automata are used to recognize strings and build a parse tree. Unlike finite automata, procedural automata uses a stack to handle nested structures, making them capable of recognizing more complex patterns such as balanced parentheses or properly structured sentences in our grammar. Now, let's proceed with the parsing algorithm. So for parsing algorithm, are used to analyze string structures according to a formal grammar. The output is typically parse tree or sub abstract syntax tree, which represents the grammar structures of the string. So in this field, so in terms of parsing algorithm, we're used to analyze the structures of string according to formal grammar. These algorithms break down the string into its components and generate parse tree or abstract syntax tree, which visually represents the grammatical structures and hierarchical relationship within the string, crucial for task syntax analysis, machine translation, and code compilation. Next, the significance for this one in terms of NLP, um, syntactic analysis. So syntactic analysis, parsing is crucial for tasks like syntactic parsing, where our goal is to break down a sentence into grammar, grammatical components, like noun phrase, verb phrases. Um, this is essential for understanding sentence structures, machine translations, and question answering. So, in this field class, NLP, parsing is essential for syntactic analysis, where a sentence broken down into its grammatical components, such as those phrases. This analytical analysis is crucial for tasks like machine translation and question answering, as it will help the system understand sentence structures. Um, and relationship between words. Now, um, for language understanding, understanding the syntactic structures of a sentence is crucial for deeper semantic analysis, which allows systems to extract meaning and disambiguate sentences. So, particularly in NLP, understanding the syntactic structures of a sentence is vital for semantic analysis, as it helps systems extract meaning and resolves ambiguities in sentences. So, here for language modeling are also used in language modeling, where they help uh, help predict how words relate to each other in a given context. So parsing algorithm class are used in language modeling to predict how words relate to each other within a given context, aiding in tasks like text generation and prediction. So for example, we do have here the earliest algorithm or CYT algorithm can be used for parsing free language, context free language, I mean. This algorithm take a string or a specific input as input and produce a parse tree that shows how the string fits into the grammar. Now, earliest algorithm or the CYT can be used here. This algorithm takes a string as input and generate a parse tree, which illustrates how the string conforms to the rules of the grammar. Now, let's move on to the regular language. Regular language, these are the examples of the regular language classes and their computational significance. So these are the simplest class of languages and can be recognized by finite automata. These languages are defined by regular expression and have low computational complexity, um, and have making them efficient for many tasks. So in terms of regular languages class, this field, we're able to, this is the simplest class of languages or automata recognized by finite automata and are defined by regular expression, making them efficient for the tasks like pattern matching and text processing. So the significance of regular language are often used for text searching and pattern matching. For example, regular expressions are used to match patterns in text, like detecting email addresses or phone numbers. So in NLP, regular languages are crucial for text search and pattern matching, as regular expressions allow for efficiently detecting patterns in text, such as email address or phone numbers. So particularly, there will be also in terms of tokenization, where tokenization are used in tokenization tasks where um, text is broken down into individual tokens based on predefined patterns. So in NLP, regular languages are used in tokenization where text is divided into individual tokens based on predefined patterns, such as separating words, punctuations, or numbers. So the example here, the set of all strings consisting of a sequence of digits is a regular language and can be recognized by a simple finite automaton. So that's the example. Well, let's actually move on to the context-free language. So for context-free language class, this is are more complex and can be recognized with precision automata. Um, they are often used to model the syntax of programming languages and natural languages. So this is more powerful, more complex than regular languages, and they are commonly used to model the syntax of programming languages and natural languages. capturing nested structures like parentheses or clauses. So the significance for this one, in terms of syntactic parsing, many NLP tasks, including the grammar-based parsing and compiling, involve context-free languages. A context-free grammar is used to define sentence structures, making CFLs essential for syntactic analysis and sentence generation. So in this field, this is gonna really essential for syntactic parsing as context-free grammar defines sentence structures, enabling grammar-based parsing and sentence generation for tasks like machine translation and speech recognition. Now, in terms of this machine translation, context-free languages help in translating text by analyzing the grammatical structures of source and target languages. So CFLs are important for machine translation as they enable the analysis of the grammatical structures of both source and target languages, ensuring the accurate translations of sentence structures. So the example for this one here, the languages of balanced parentheses is context-free language which can be recognized by a push-left automata. Since we're not able to work on that in our automata, after na siya sa CFG, after they were able to remove those um, mga stop point, mga nullable, we're able to stop there. Then after that one, we need to discuss the CFG and then the GNF. Afterwards, they push them automata already. So context sensitive language, let's proceed here, are more powerful and can be recognized by linear bounded automata. This language allows for more complex grammatical rules that depend on the context of symbols in the string. So meaning to say, they allow for more complex grammatical rules that depend on the context of symbols in a string, making them useful for modeling intricate structures in natural languages. So the significance for this one will be in terms of complex syntax. CFLs can model more intricate syntactic rules that are needed for languages with dependencies beyond context-free grammar, with such as certain natural language constructs. And NLP, CSL are significant for modeling complex texts as they can represent more intricate syntactic rules, as being mentioned, needed for language with dependencies that will be on the capabilities of CFG, such as certain natural language constructs. So we also have here for the translation, some parts of machine translation may require context-sensitive model to correctly translate sentences with complex syntactic structures. Meaning to say, this will help accurately translate sentences with complex syntactic structures that require dependencies beyond what context-free models can handle. So let's actually move on here with the example. Context-sensitive languages are useful for modeling languages that can require dependency relationships between non-adjacent elements such as agreement in gender and number between subjects and verbs. So the example. Now we also have here then for language classes provide an essential framework for understanding the structures, complexity, and computational requirements of different types of formal languages. So in NLP, these classes and their operations form the foundations for designing efficient algorithms for text parsing, semantic analysis, machine translations, and other key tasks by understanding the computational significance of each language class. NLP practitioners can select the right models and algorithms to process natural language data efficiently. Meaning to say, these language classes will provide a crucial framework for understanding the structure, complexity, and so on of different formal languages. Since in NLP, these classes and their operations form the basis for designing efficient algorithms like the text parsing, and so on and so forth, allowing us to select the most suitable models and algorithms for processing natural language data effectively. Now, role of linguistic formalism in defining languages. So, linguistic formalisms are structured approaches, which we'll begin to discuss in a while in different videos, that define, describe, and model formal languages, enabling computational systems to process natural language in a systematic way. This formalism includes syntactic, semantic, phonological models, each playing a crucial role in the NLP pipeline. So, linguistic formalism are structured approaches that will define, describe, and model formal languages as it will allow computational system to process natural language systematically. Those formalism includes those syntactic, semantic, and so on, which will help system analyze the sentence structures, meaning, and sound patterns. So the significance syntax modeling, linguistic formalism helps in terms of defining the grammatical structures in NLP. I mean in defining the grammatical structures of natural language. Syntactic formalism like CFG describe how words can be combined to form valid sentences. So um, it will describe how words and phrases can be combined to form valid sentences, enabling accurate syntactic analysis and syntactic parsing so far. Now, let's move on to the semantic and phonological models. Beyond syntax, formalism also extends to semantic analysis, understanding meaning, and of course, the phonological rules, which is representing sound structures which are essential in advanced NLP applications like machine translation and speech recognition. So therefore, semantic formalism will strengthen this one, both of which are essential for advanced application like machine learning, translation, and speech recognition. So the significance in terms of text representation, formalizing the structures of language makes it possible to build um, sys- computational systems that understand language by adhering to predefined structures and relationship. So in text representation class, they form, formalizing the rules of language enables computational system to understand language. So by adhering to predefined structures and relationship, these systems can process and analyze this effectively for various tasks like parsing, translation, and sentiment analysis so far. Now, there will be two of the most widely used linguistic formalism in NLP is the regular expression and context-free grammar. So for that one, are a sequence of characters that define search patterns and text. These patterns will allow for matching sequences of symbols within text, making them indispensable for pattern and recognition in computational systems. So we're able to learn that already in our automaton. And in terms of regular expression, it is significant in terms of pattern matching. Are used extensively in tokenization, text searching, syntax checking. For instance, they help identify valid email address or phone numbers in text. Then, in terms of flexibility, they will allow for defining complex tasks, text patterns with simple annotations, making them useful for search engines, data cleaning, and filtering tasks in NLP. Then, example, the regular expression, um, the backslash D class can be used to match one or more digits in a string. Now, context-free grammars is a set of production rules used to define the structures of valid strings in a language, as these grammars are used to describe hierarchical structures such as the nested phrases in natural languages sentence. We're able to define that in our automata already. This is significant in terms of the syntax parsing. CFG are the backbone of syntax tech analysis in NLP, where they help to determine the grammatical structures of sentence. For example, they help break down the sentences into noun phrase and verb phrases, enabling sentence parsing. So in terms of machine translation, in machine translation, this is actually being used to analyze and generate syntactically correct sentences in both source and target languages also. An example, simple CFG rule for a noun phrase might be noun phrase. It could be the determiner and noun, where determiner stands for determiner like the noun, like the, and noun stands for noun like the cat. So closure properties describe how certain operations and languages, such as the union and so on, affect the resulting languages. A language class is closed under an operations if applying that operations to languages in the class results in a new language that still belongs to the same class. Of course, as what we mentioned earlier, this is the important thing in order for us to build a new sentences, and that is still valid since that is belong to that is a subset of that particular set still. Now, in terms of NLP, predictability in operations, understanding closure properties is vital for ensuring that operations are applied to formal languages do not lead to results that are too complex or computationally expensive. For example, operations on regular languages should not result in context-free or more complex languages unless explicitly designed to do so. Now, in terms of the significance in NLP, efficiency, knowing which operation preserve the complexity of a language allows us to design efficient algorithms for NLP tasks such as parsing and pattern matching. Now, regular languages are closed under union, concatenation, and clean closure. This means applying these operations to regular language will produce new language that are still regular. And then, regular language are closed under union. This means applying the operations will produce the language. Yes, that's actually the end of our lesson. Thank you so much. Hopefully that you were able to grasp those important thing, since here in NLP more on theoretical, so make sure to really understand those. If you wanted to really expand, you can actually search for more. And if you have question, you can put that in the comment section. And for your task for this video, I want you to formulate the 3 sentences as one of your to explain what will be your takeaways in terms of this discussion. Thank you.